Hey everyone, it's Thursday. So today we're going to be working on drawing polygons in the coordinate plane. You should have already reviewed our vocabulary term of the day, which is vertex. Vertices is the plural form of it, and its meaning is on an angle or polygon where two sides intersect or meet. For number one, the given points are the ordered pairs that we need to plot on our coordinate plane. Remember, this is quadrant 1, 2, 3, and 4. And when we're doing this, we need to look at our points. So 3, comma 2. We do x, then y. On the x-axis, we need to go 1, 2, 3, 1, 2. So we go right there. And that's going to be point A. Plotting point B, it's 3 positives. 1, 2, 3, up 7 on the y-axis. 1, 2, 3, 4, 5, 6, 7. That's point B. And then now for C, we're going to go on the x-axis 8. 1, 2, 4, 7, 8, up to 1. So actually all of these points are plotted in quadrant 1. Once I plotted all of my points, I then connected them to create a line segment, which ended up creating a polygon, a three-sided polygon actually. And those types of polygons are a right triangle because it created a 90-degree angle right in the corner of A. You could see that if I did this square right there, that would create a 90-degree angle. The next question is asking for how many vertices. Well, vertices are what connect at any endpoint. So technically, that's vertice, and that's vertice, where two lines intersect or meet. So we have 3 vertices. Next, we're going to be looking at our base, which is the bottom. It's the line segment AC. That's actually our base. And it creates, we're going to our line, 2, 3, 4, 5. So our base would be 5. And we don't know the measurement, so we're going to say it's units. And our height would then be, let's make it a different color. 1, 2, 3, 4, 5. So since there are already a horizontal line and a vertical line, we didn't have to compose it into a square rectangle and break it apart. We already know the area formula, so this one was pretty easy for us, but in case you didn't know, we could have created an imaginary line going from here to here, found the total area, and then cut it in half because that's what our shape is. Our right triangle is half of it. But since we didn't have to do that, we're just going to this. So area formula for a triangle is base times height divided by 2. We know our base and our height. We're going to substitute those in. 5 times 5, that's the same thing, divided by 2. So you get 25 divided by 2. And when you do that, you get your area to be 12.5 feet squared. And I boxed my answer, but I'm also going to plug it back in until where it says A equals, that means area equals. Okay, and for number 1, it should have been 12.5 units squared. I just caught that while I was clearing my ink from the page. So go ahead and forgive me. Your number 1 area should be 12.5 units squared because we didn't know the type of measurement, so we did units. Now we're on number 2. So the ordered pairs are listed above for point D, point E, point F, and point G. Miss Peak, if you could go ahead and pause me, I want the students to try to go through and graph those ordered pairs on our coordinate plane. Okay, so I have plotted my points. Yours should look the same. Remember, we do X and then Y when you're graphing, so that would be X there, Y there. X there, Y there. And sometimes I do this just so I don't get confused, so I clearly know what I'm graphing when you're doing on the coordinate plane, because especially if you're graphing a bunch of points, it could get confusing. Once you've graphed that shape, The type of polygon that is a rectangle. You would fill that in on number 2. How many vertices this has? Well, we could do that by going through and seeing, well, all of our points that intersect. Here intersect, that creates one vertex. Here intersect, it creates another. There, 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 and there. So you have 4 vertices. Again, we could find the base and the height of this one pretty easily because there are 2 horizontal lines, this and this. And we also have 2 vertical lines going this way and this way. So if we look at our base here, our base would either be line segment DE or line segment FG. And if we do that, we get 1, 2, 3, 4, 5. So our base would be 5. Again, we're going to be talking about units. And then our height could either be FD or line segment EG. That's going to be 1, 2, 3. So our height would be 3 units. We already know the area formula for a rectangle or a parallelogram is our base times our height. So if we were to do that, base times height, we would substitute our base and height in. We have 5 units times 3 units, which gets us 15 units squared. And you are just going to go ahead and plug that in into your area, which A equals, we're talking about area equals 15 units squared. Our last example, number 3, before I send you off to work in partners, are the ordered pairs here. Point H, point I, point J, and point K. Miss Peak, if you could go ahead and pause me. Again, I want the scholars to try to graph independently. I have plotted my ordered pair and created a polygon on my coordinate plane, as you should have already. The only one I thought may be difficult for some of you is point J, how it's 0, -5, which means x is 0 and y is -5. So when you're plotting on the coordinate plane, you really need to make sure you know exactly where you are. So on the x-axis, the horizontal one, 0 is really right here, which also y is 0 there as well. But if you're going, if point J says y is -5, you need to go down to -5, which ends up getting you on point J. The specific type of polygon this is a trapezoid. It's also a special quadrilateral because it has 4 sides, but more specifically, it's a trapezoid because it has one set of parallel sides. How many vertices does this polygon have? Well, angle HKJ form 1, angle KHI form a vertice, angle HIJ form a vertice, and angle KJI form another vertice, leaving us with 4 vertices. And so since this is a trapezoid, we do have 2 horizontal lines. AJ forms a horizontal line segment, and line segment HI form a horizontal line segment. So we don't really specifically know a formula for area, but we do know that it can create 2 triangles. So we've been working with that. If we create 2 triangles, creating 2 triangles, we can go from point H into an imaginary line to point J. And you also could have done point K, point I. We're only going to solely focus on one. So right now I'm just going to focus on drawing an imaginary line to point from point H to point J. So let's focus on this bottom triangle right here, HKJ, triangle HKJ. The base of that is going to be 1, 2, 3, 4, 5, 6. And again, we need to create our height. So we're looking from the tippiest point of our triangle to our base. So I'm going to create an imaginary line right there, which is also the same thing as if we created it right here, because these are going to be the same length. So if I want to find my height, I'm going to do 1, 2, 3. I'm not going to be looking at my other triangle, HIJ. And when I look at that one, my base is going to be 1, 2. My base is along right there. That creates 2 units to be my base 2. My height, remember, is still going to be 3 units because if I create this imaginary line right here, it's going to be on the y-axis, so it's kind of hard to see. Really, that's the same height from the tippiest point of our triangle all the way to our base. Tippy toppest point to our base. Now that we know the base and height of both of our triangles, we can add those 2 triangles together to find our total area of the trapezoid. We know that base times height divided by 2 will get us the area of one triangle. So for triangle 1, we have base times height divided by 2, and we're going to substitute our base and height in. We have 6 is our base times 3 is our height divided by 2. 6 times 3 is 18 divided by 2, which end up getting us 9 units squared for our area of this triangle 1. We're not done because we're going to find the area of the total triangle. We only found the area of a part of it. So for triangle 2, we're going to be doing the same thing. Base times height divided by 2. Our base in this case is going to be 2 units, and our height is still 3. We're going to divide that by 2, and we get 6 over 2, which ends up getting us 3 units squared. But we're not done yet because we only found the area of triangle 1 and then the area of triangle 2. To find the total area of the trapezoid, we need to combine these 2 areas together to find our total area. We have our area equals 9 units squared plus 3 units squared equals 12 units squared for our total area of the trapezoid. Really make sure your work is looking like mine, hopefully not as sloppy. It's kind of hard to write on this computer screen, but really make sure that you're having because if you leave out some silly mistake and you maybe do a multiplication error up here, I can see that you still know how to find the area, but you just maybe rushed the problem and made a silly error. Really make sure you're showing all of those steps for me. Okay, so I now filled in my 12 units squared there for my area, the total area of the trapezoid. Really make sure that your answers are clear, that you know what vertices mean. If you need help, you need to follow the temptations, be looking at the exemplar when you're working with your partner, and raise your hand if a mistake is found or if Ms. Shutters is in the room.